Welcome, ladies and gentlemen. You're looking at recent images of the sun. This portion of the sun is actually in the pocket of the second wind. Nibiru, Planet X, is off to the left and up about 30, 40 degrees above the top of the sun. Notice the flashing, though, going over the surface. Light, dark, light, dark. That flashing has been showing up on other instruments as well. We're going to keep an eye on that. We switched to 17 nanometer radiation, which is a higher energy than the 30 nanometer we were just looking at. And you see how the cooler plasma, it gets lost, and we start seeing loops that extend out into the corona. It's a nice little overlay there. And the 17 nanometer is created by electrons. So that's why you see the loops further out in the corona than you do with the 30 nanometer, because way out in the corona the particles are less concentrated than they are on the surface. So that's an interesting overlay. I love it. You get to see the darker plasma, you get to see the electron loops as they extend way out into the corona, further out than we've seen in a long time. And partly because there's more electrons in the solar system, and partly because there's more helium and particles in the corona. It's really a neon-like light where you run electrons through a gas. And if you want a brighter light, you get more gas concentration in your tube, or more electrons running through your tube. Either way, it creates more light. And we think the 171 angstroms, or the 17 nanometer images, have been cropped so you can't see further out into the corona, because we started calling these solar auroras when we were the first people on planet Earth to point it out to you. This incoming sunspot's been very active. Produces M flare and an X flare. The X flare was recent, but had been redacted for days off the imagery, and we'll show you some of that. But notice the plasma just pouring in. But then when we switch to the 17 nanometer, the really extreme ultraviolet, again, that can only be created by an electron event or a cascade, collisions. So the brightest of the 17 nanometer occurs where we have the greatest electron concentrations and the greatest activity, the greatest changing in directions. That's why some of the times the top of the loops light up, because that's where electrons are being forced to change direction. And changing of the direction of an electron releases all kinds of electromagnetic and photon radiation. We look at the bottom of the sun just to see if we can see pinpoint emissions. We still seeing them. We're not seeing them come through in the waves like we have. We pull away from the sun using LASCO C3 telescope, and we do see a lot of background stars that you normally can't see under the white light. That kind of obscures the flashing that's going on. But notice the flashing is definitely more prominent in the corona than it is near the surface of the sun, because that's where the particles are coming from. They're coming from out. So we went and tried to find the X flares and the M flares. I believe this is the M flare on the 13th, and you can see half the flare was redacted. They erased through it. Hard to show you precursor events. They just show you as little as possible now of these flares. I'm going to a different day. This is the 14th. This is the next day, to see what we can see. This is stereo. Excuse me. This is C2, and we see a flare gets cut off. And I do believe that's the X flare, and there's no reason for it to get cut off. You see it just cutting off, starting off to the left of the occulting disk, and then it disappears. It didn't disappear because the clock turned over to the next day, and so the images go on the next day. But so, and then of course the current images weren't even listed. So then we go down to stereo A instead of LASCO C2, and we do see on the 14th that flare that appears to have been cut off. That could have been one of those larger flares. And the thing was, is the sun chain reacted. The sun just kept pumping flare after flare after flare, and it's hard to call that. We can call those chain reactions. We can warn you that's happening if we get enough images, because there are precursor events to these type of chain reactions. Here on the next day, on the 15th, you see two flares. 1, 2. That's not a repeat of the same flare. That's a repeat of a CME coming from the same sunspot, but they're two different flares. So we've seen 4 very forceful, very high-speed ejections. At least they look high-speed because they're giving us very few frames. But there's 4 or 5 that just boom, 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 right in a row. And we would like scientifically explain what's going on and prove it with images, but no, not with what they're providing us anymore. On the 16th, we did have additional flaring, and then we're going to go back, I believe, to the 13th and get that first flare that was cut off. And there it was, boom, that's a pretty big one. And again, just like LASCO, the stereo satellite, a different satellite, the images again were, just a few. And they could provide 5 images per second, 10 images per second, but you're probably seeing 20 to 30 images per second. So things are just flying by, and they don't show you the very beginning, and they sometimes don't show you the very end. So this is a CME catalog, which I love, and so I wanted to get higher quality images, and you can get higher quality stereo A, really quality stereo images, stereo A, off the SETI database on this platform. They run about a week behind. You can see down there, we click on our month, and the month will pop up here, and you see they only have it updated till the 7th. So it runs about 10 days behind, but let's click on the 7th and show you the higher quality stereo A imagery that gets upgraded. 10 days after it gets actually released. And you see we do have a significant CME activity starting as early as the 7th. And we've been having geomagnetic storm almost daily now, and they're not really identifying correctly the source of those CMEs. The source of those geomagnetic storms. Either we're having Earth-directed solar flares every single day, or a coronal hole stream every single day. But if this kind of activity, geomagnetic storm activity, occurring on a daily basis now, what's going to happen when we reach full solar maximum? Now, an anomaly showed up on this. To me, at the 12 o'clock position, it looks like an actual CME, like cone-shaped CME. The bottom looks like an anomaly. However, the instrument did measure a CME coming out of the 7 o'clock position on that disk. But we see that anomaly all the time on the lower left. So I don't think that's anything but a flaw in the imagery caused by cosmic ray striking the camera. So that's the 7th of April. Now we go further away from the sun. We go back to the 14th, on LASCO C3 satellite, and trying to look for those pulsing CMEs. And now we're back on the 13th and the 14th. So they cut the 13th off, 14th. But notice how, we're running this straight through. We're not cutting from day to day. But notice how we're not getting a full stream of the time. We're getting just chunks and pieces of imagery that really doesn't show us all of these events right before they unfold and right all the way after they unfold. And that's usually helpful to see the entire event and the entire sequence of all the events. But it's kind of hard to do that when they're messing with the imagery. Excuse me, we did have an X-flare. They called it X-flare. That imagery is not available on HelioViewer. And we'll show you some still frames of that X-flare. I don't know why I want to keep calling it a C-flare. But it's important to realize how these transpire so you can predict them. And the speed at which they leave, the shape, everything could be valuable information in determining the nature of the second wind. For example, one of these CMEs twisted off the sun. Now, why do some come out like a parachute? Then why do some come out like a tornado and twist? And we know the answer to that question, but if you can't even see the twist, then it's kind of hard to even have a discussion about it, isn't it? So they make it very hard now for the Higher Truth channel to fully analyze what's going on. And you see some of these are just leaving the sun so quickly, and they're jerky, and it looks like a old-fashioned movie with jerky movements. And so it's very, very difficult to explain what's happening. It makes it difficult to predict what's going to happen next. Here's that X1 flare occurring on the 17th on the incoming limb, and that may still keep popping off. We'll have to see how that goes, but I can't wait till we get at least some imagery on that. You can go wait 10 or 12 days and you'll get more images and higher quality images, but they're so far after the fact, they're of minimal scientific use. They're still scientifically useful, but as far as predictions, they make it very hard for you to predict anything. But the sun is acting up, and it's a double whammy. It's a give and take. These CMEs are trying to push the cosmic rays out of the solar system, but the more sunspots you get, the more X-rays you're getting just in your background, and the more geomagnetic storms you're getting, as you can see. So if your background radiation is already high, and you add to that exacerbated CME solar storms where a C flare causes a KP index 7, then the CMEs are helpful, but it's kind of like chemotherapy. It's kind of a rough and tough medicine to get rid of these cosmic rays. Sometimes the treatment seems almost as rough as the actual problem. So again, when they're not warning you of KP index 7s and KP index 6, they're telling you it's going to be 3, 4, and 5, and they keep showing up as 6, 7, 6, 7, 5, 6, 7 KP index. It's hard to take precautions against that extra radiation. Once again, the people that are most susceptible to cosmic and solar radiation are children and anything that has fast growing, rapidly dividing cells, very active cells. Well, the most active cells in your body, even if you're not a child, happens in the brainstem that controls your heartbeat and your heart itself. Those are very active cells. They're always on go. They're always working. They never rest. So that's why when they did studies on cosmic radiation causing brainstem damage in animals, they identified the brainstem as the source of most of the neurological damage of cosmic rays, cosmic radiation on rats and of course mice. So take precautions, and we're going to try to be the ones that predict these solar storms, these KP indexes, better than what NASA's doing. Because if you go on to the Solar Ham website, you'll see many of these KP index 5, 6, and 7s aren't getting predicted very accurately. So until next time, we're going to work on that for you. And thank you for listening.